Okay, YouTube, in this video we're going to be basically going over how we find products and quotients with complex numbers, but doing so not in standard form, but in trig form. And actually, one would think, as a matter of fact, we can just go ahead and write this out here. We say standard form of a complex number, recall, is some real part plus some imaginary part. This would be standard. Where the trig form, we're saying, instead of telling me how far left, right, up, and down to go in order to get to my number, we're saying, tell me how far to go and in what direction we're heading in. So we have cosine theta plus I sine theta, or we tend to just write this as z equals r cis theta, cosine I sine theta. So we have our trig form right here. What I'm going to say is basically we want to most of the time be multiplying complex numbers in trig form and not in standard form, because imagine this, when you have two numbers that are in standard form, real plus imaginary, you end up having to FOIL and simplify your powers of i's, and you know what, even division, a plus bi over c plus di, we have to do this multiplication by the conjugate of the bottom just to get rid of this here and then simplify that. So it is much easier to deal with these in trig form, and I'm going to basically lay out the rules for multiplying and dividing in trig form, and then we'll just do a couple problems and talk about how simplistic it actually was. So we have some z1, this is our complex number 1, and we say that this has some distance from the origin r1 and some direction theta 1, and z2 we have just some r2, theta 2 is the direction, and r2 is its distance. So if we're going to multiply z1 by z2, then really all this says we're doing is we're going to take r1 times r2, which is multiplying their modulus values in the front here, and then just adding theta 1 plus theta 2, where this is the direction of the first number to the direction of the second number. So to put this into practice, we would say that if I have two numbers here, we're calling this one here z1 and this one z2. The thing is, we already know their modulus values are 4 and 6. So according to this definition, we get 4 times 6, and then on the inside we get cosine of 120 plus 315, which when you add those together is 435. So we get 435 plus I times the sine of 435. So 435. I'll try to squeeze that in there. So this is very true, and as a matter of fact, we could just simplify this here. We get 24, and really we could just say CIS, and we add the two arguments here. Clean that up here. Add the two arguments. So we get 120 plus 315, we said, is 435. That was it. I mean, this is all you have to do. And as a matter of fact, converting this back to standard form, you get the same thing as if you had done it thusly. But the thing is, this is a little bit cleaner to do and a little bit easier to do. One comment I have about this 435 before we kind of proceed is this. I would say that 24 CIS 435 would mean that I'm going in a 435 degree direction, which means full 360 plus how much more. So if we were to take 435 and subtract off 360, we say, okay, well, 435 minus 360, we'd have to go another 75 degrees, which would mean it would terminate about right here. Instead of telling ourselves that our complex number really is this far, 24 units out from the origin in this direction right here, we could say that it's 24 units out. That's fine, but I would say really in a 75 degree direction. So the point I want to kind of draw upon is this: 24 CIS 75 is the same complex number because you go in the same direction and you have the same modulus value. So that being said, we should always keep our arguments or angles somewhere between 360 degrees and 0, and including 0 degrees. We can do 0. So now, really quickly here, let's look at this last example. On the last one we just did, when you multiply two complex numbers, you multiply the arguments, and you multiply the modulus values, and then you add the arguments. In this case, when you divide two complex numbers, you might infer that you divide the two arguments and that you do the opposite of add, but you subtract the two argument values, which is very true. If you look over here, we say z1 divided by z2 is the r1 from the first number divided by r2, which is the modulus value of the second number. So you just divide the modulus values, and then instead of adding the arguments, you subtract them, and order does matter. We're always going to subtract theta 2 from theta 1. That is, subtract the denominator's angle from the numerator's angle. So this right here would just be equal to 15 over 3, and then we would get cosine of, and I'll write this one out here, we say 240 minus 135 plus I sine 240 minus 135, okay? So we have our r out front, quotient of r's, and then subtraction of the arguments. But we basically could have just written, hey, it's 5 CIS, and 240 minus 135 would be 105 degree angle. So basically, this quotient right here, we could say that it's going 5 units and 105 degree angle. So we would say that maybe this is not drawing a vector here. I guess we're drawing a complex number. We could say that this is our number right here. It's heading in a 105 degree angle, and it's heading out 5 units from there. So there's our right triangle. That's how you multiply and divide with numbers in trig form. Pretty simple.